All right, let's do some Mathity-Math. It says write the following displacement as a column vector and then in ij form. All right, before we jump into this, let's kind of prepare ourselves for what we're going to be doing here. If we're going to give the answer as, oh, you can't even see that. If we're going to do the answer as a column vector, that means it's going to be the x value over the y value in this matrix. That would be our answer as a column vector. If it's ij form, it's going to be a value with I plus a value with j. That's going to be ij form. So this is where we're going to be plugging our answers into. Our answer is going to look something like that. Okay? So going here, it says it's 22 meters on a bearing of 210 degrees. Okay, so this is the 22 meters coming down. Let me just scoot down for you guys a little bit. Okay, and the 210 degrees. So let's start with the 210 degrees and really kind of see what this is telling us. So if you really think about it, if you came down and you kind of drew your xy coordinate plane or your xy axis, if you came down this far, that would be 90 degrees. And if you came farther, that'd be another 90 degrees. So right now you're at 180. Okay, and then it said that the total was 210. So from here to here it's 210, but you know from here to here it's 180. So you know that last bit is just 210 minus 180, which is just 30. Okay? And extending that logic, you know from here to here would be 90. Well, if that's 30, this last little bit would be 60. Okay, 90, 90, 90, that would be 270, and you can reverse this and make sure you didn't make a mistake. If you're here all the way up to here, that's 270 minus 60 would be 210, so you know you're on the right track. What this does is let you realize that inside this triangle, we now have one angle, which is 60 degrees. We have the others 90. We could also fill in this one if we wanted to, but we don't need to. And we also know the hypotenuse. And in essence, what we're trying to find here is when we talked about those xy values up here to go into the column vector, it's really asking you, well, what was this x value here and what was this x value here that led us to this resultant vector, okay? So really, we're just going to a triangle and we're trying to find these two sides. Now, when you have a right triangle, typically there's two places you go, A, Pythagorean theorem, or B, right triangle trigonometry. In this case, because we only have the one side in the angle, we're going to use right triangle trigonometry. Okay, I'm going to go back up here and kind of write a thought bubble to help you guys kind of remember your ideas. Right triangle trigonometry just tells us that we can say sine of a reference angle is the same as the opposite over the hypotenuse. Okay, the cosine theta, or the angle we're referencing, would be the adjacent side over the hypotenuse. And the tangent of an angle would be the opposite over the adjacent. And the key to figuring out these, which one you want to use, is looking at what you have. So if we come back down here real quick, like, you can see, well, we have the hypotenuse and we have the angle. So we have two of the three parts, okay? So we want to go up here. We're going to choose the ones that have the angle. That's all of them. Ding, 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 ding. So we're going to plug that in. And which ones are using the hypotenuse? Well, that is sine, because it's using the hypotenuse, and the cosine uses the hypotenuse. So we can plug that in, and that'll let us isolate the one piece we don't have. So coming down here, we have our reference angle of 60. That's what we're going to use for all of them. So it's going to say sine 60 degrees, see I'm just plugging in for theta, is opposite over hypotenuse. We don't know the opposite, but we do know the hypotenuse, which is 22. Okay, I'm going to let that sit for a second and come down to our triangle and make sure we understand what that means when we say opposite. So this opposite, what it's saying is, well, we're referencing 60 degrees, this 60 degree angle. What side is opposite that 60-degree angle? And that would be this side. So that opposite we're talking about is this side right here. And later on, when we use the adjacent, well, the adjacent is typically the one that kind of runs on the same side and it's not opposite. So this would be the adjacent. And the hypotenuse is always across from the right triangle, so this is your hypotenuse. So you see this h is 22. That's why we plugged in the 22 for h, okay? So I'm going to set both up, and then we can just run away with this, okay? For the cosine, which we're using, this will help us find the adjacent side. This adjacent side, we just say cosine, we're referencing 60 degrees, is, I don't know this, so I just leave it as a, over the hypotenuse, which I know is 22. Okay, so now I can just go do this math. Just get this stuff out of there, and we can focus on the problem at hand. Okay, so if I want to isolate this opposite side, I got to get rid of this 22. I do that by just doing basic algebra. I multiply both sides by 22. That would cancel, and I would get left with 22 sine 60 degrees is, and this would tell me the length of the opposite side. And we just do this in our calculator. When you get your calculator, do make sure it is in degree mode, and you just punch in what you see. 22 sine 60, you get 19.052558888. We're going to go to 3 sig figs, so we know that this opposite side is 19.1. Okay, that is a good value. Good job. All right, looking here for cosine, again, we just multiply both sides by 22 to make that cancel, and we're going to get 22 cosine 60 degrees. Plug it in, 22 cosine 60. You get 11. All right. So this tells us now the length of our opposite side is 19.1. I can put that right here, 19.1. And the length of our adjacent side is 11. I can put that right here. And there's one thing we got to be very careful about. You see, this is the y coordinate plane, right? I'm sorry, the xy coordinate plane. And we're over here in the third quadrant, which means we're moving back and we're moving down. So when we do our x's and y's, when we move back, we actually want to think of this as a negative 11 because we're giving directions. If we would have left it positive, it would imply we're supposed to be way over here. And if we leave this positive, it'd say we're supposed to be way up here. So because we're telling people, or it's giving instruction which way it's traveling, you got to make those negative. And at this point, all we have to do is put our answers back up here like we talked about. So I'll write the answers right here. So the x value is negative 11. The y value is negative 19.1. That right there is a column vector, right? X and Y. Good job. And then we just have to put it in ij form. So my I value is negative 11 because that's the x. So I have negative 11i plus negative 19.1j. And voila, that's it. That is what the question asked us to do, and we did it, and we did it well. Okay, as always, if you want to be notified when I make more practice problems just for you, go ahead and subscribe below. And if you have any comments or questions or something was unclear, just leave a comment below and I'll do my best to answer any questions you have or make the problem a little bit more clear for you next time. Alrighty, thank you. Bye.